This is problem number 5 from the Chapter 9 closure packet. Brian was holding a ballroom dance. He wanted to make sure girls would come, so he charged boys $5 to get in, but girls only $3. The 45 people who came paid a total of $175. Write a system of equations to find how many girls came to the dance. So the key thing is here, it's a system of equations. We've been doing a lot of inequalities, but this is equations, so they're going to have equal signs in there. So we're going to write one equation about money and one about the number of people. Okay? But first, let's figure out what are our variables going to be. If we look at the question, or kind of the last question or last sentence of the paragraph, write a system of equations to find how many girls came to the dance. So one of our variables has to be the number of girls. So I'm going to write those over here. So G equals the number of girls who attended, and the other variable is going to be the number of boys. I'm going to say B is the number of boys. You can use X and Y or other variables as long as you say what they are over here. All right, so back to our equations. One is about money, one is about the number of people going to the dance. So let's talk about the money one first. It's $5 for every boy, so 5 times B. If I have 2 boys, I would do 5 times 2, and that would be $10. Okay? Plus $3 for each girl, so 3G. And it was a total cost, people who came paid a total of $175. So 175. Now I've used all of those numbers one time. I cannot use them again. So those numbers are gone. Okay? In the next equation, I have the total number of people is 45. So something equals 45. Well, what kind of people came to the dance? Boys and girls. When we said girls is G, boys is B. B plus G equals 45, the total number of people. So from here, you can do one of 3 strategies. You can do substitution, equal values, and elimination. So I'm going to do elimination. Okay, so that's when we stack our equations on top of each other, and we're going to have to probably multiply one or both equations by something to make a variable cancel out. Okay, so I just stacked them on top of each other like this. Now I'm going to try to get the g's to cancel out. So that means this 3g, this needs to be negative 3g. So I'm going to multiply this whole bottom equation by negative 3. Okay, so I'm going to write them over here. The top one just stays the same. All right, now I'm going to multiply everything by negative 3. So negative 3b minus 3g equals negative 135. Okay, so if I were to add my equations together, 3 plus negative 3, that's 0. So make sure you add, you're going to add everything together, all of the equations, or all the parts of the equation. So these we know cancel out, that was the goal. 5b plus negative 3 is 2b. This is gone, equals 175 plus negative 135 gives me positive 40. Okay. So now I'm going to divide by 2 to get rid of the b, or to get the b by itself, rather. So I get b is 20. So there are 20 boys who attended. So I'm going to write that over here. 20 boys. Part of our answer. Now the question really asked for the number of girls, so that was great, but I'm going to use that to find the number of girls. So I'm going to plug that into this equation here. Boys 20 plus G equals 45. I'm using this equation right here. You can use the other one. This one just looks easier. So if I subtract 20 from both sides, I get the number of girls is 25. So I have 25 girls who attended. Okay? The real answer is just the girls, number of girls. So we don't need to say that, but you still can. Okay? So a system of equations, you write 2 equations, one for money, one for the number of things, and then solve it using either elimination, which is what I did. You could have used substitution and solved this equation for B or G and then plugged it in. Or the third method is equal values method, and I have to solve both equations for the same variable. So that one takes a little bit more steps to get to if you want to use that method. And then we solve for the number of girls.